So part G of number 19, it says construct a box and whiskers diagram. Interpret the skewness and compare the relative sizes of the mean, median, and mode. So the box and whiskers is a very popular way, very powerful way of representing data using a diagram, a picture with 1,000 words. And for help now, we can go to this YouTube video or we can go to week 3. Let's go to week 3 first, or unit 3, and then we'll come to this video. And also I will show you how you can easily construct a box and whiskers using a box plot calculator. You can even look it up now, a box plot calculator online. So we don't have to do old school, taking a pen, a pencil, a ruler, a pencil to construct manually. No, you can do this very easily using softwares. So here we are in unit 3, representing data using a box and whiskers diagram. It's normally called a 5-number summary. It says a box plot or box and whiskers plot can be useful for handling many data values. They allow people to explore data and to draw informal conclusions when 2 or more variables are present. You can do comparison analysis. It shows only certain statistics, meaning certain descriptive measures, rather than all the data. So it's only using 5. Okay, and the 5 numbers that it is using is the median, the quartiles, and the smallest and the highest value. The lowest value, the lower quartile, the median, the upper quartile, and the highest value. 5 numbers. That's why they normally call it a 5-number summary. So for writing purposes, I can grab this, even though you have it in the unit, and I'm going to write it now. Look, I'm writing. I've just written on the whiteboard. Here it is. Click over button and we have written. Now, if you have to construct the box and whiskers manually, here are the steps. First, you record the lowest and the highest value. Then you have to calculate the quartiles, the median and the lower and the upper quartile, the 3 quartiles. You've got to calculate them. And you've got to, so that will be your 5 numbers, 1, 2, 3, 4, 5. And you have to draw a line for scale, a horizontal scale, as you can see. Here it is. In that case, the example is from 0 to 100. That starts with the lowest value or a little less than it, and ends with the highest or a little more. And you draw vertical lines at the positions of the 5 numbers. The lowest, median, lower quartile, median, and upper quartile, and highest value. Join this line to form a box. So you join the quartiles to form a box. You make a box with the quartiles, and that's where the majority of the values are. So anytime you see you looking at a box plot, the box will indicate where most of the values are. So you can easily conclude in whatever data set this was, most of the values were between 50 and 85. The majority of the values. Some of them, you have the lowest was around there, 15 more or less, 17, 16, and the highest was probably 100, but most of them were in that region between 50 and 85. For further analysis, you can calculate what you call the upper fences, or the lower fence and the upper fence, but this is not really mandatory. Then how do you interpret a box plot when you see one? You've got the shape. If the median is near the center of the box and each horizontal line is of approximately equal length, each whisker is more or less the same length, then the distribution you can conclude is roughly symmetric, which means that the mean, median, and mode are basically more or less equal to each other, and the majority of the values are located in the center of the data scale. However, if you find your box on the lower end of the scale, it means most of the values are there on the lower end. And this distribution is skewed towards the right because the box would have to move towards the right to be centralized. So the skewness is where the longer whisker is located. It's not where the box is located. Please don't confuse. The skewness is where the longer whisker is located. The direction that the box have to move to be centralized. So this distribution is skewed to the right. Because on our number line, towards the right is considered the positive direction. So you can safely say that this distribution is positively skewed. So you can say skewed to the right or positively skewed. Now the box may appear on the higher end of the scale and it has to move towards the left for it to be centralized. The longer whisker is on the left. So this distribution is skewed towards the left because towards the left is a negative direction on the number line. Then you can say this distribution is negatively skewed just by looking at the box plot. And always bear in mind where the box is, that's where most of the values are. So in a data set like this, you know, the mean, the median is around 20 something, okay? Most of the values are around there. So that's what you do when you have constructed the box plot. Now, how to construct the box plot manually? We have gone through this. You must obtain those 5 numbers.